section 7.6. Surface area and volume of spheres. So a sphere, a sphere doesn't have a base. Really has just a one curved part that makes up the whole thing. So we don't have to worry about bases, we don't have to worry about heights, we don't have to worry about slant heights. There's really only one thing that we have to that we need to know for a sphere. But so we'll just call it, for now, it's not a polyhedron. We're not going to give it a special name. So we're just going to call it a three-dimensional curved surface. And just to be a little more technical about what a sphere is all points that are the same distance from a center. And we call the distance the points are away from the center, the distance is the radius. And the radius is really the only part of the piece of information we need about spheres. So let me grab a sphere here. If you wanted to draw a sphere, what I usually do is just sketch a circle and then kind of make an oval around the middle. So that would be a really rough sketch of a sphere. Let me grab a better picture here. Go. All right, so just like we would expect for a sphere, the point right here is the center. This segment is the radius. And this segment that goes all the way across is going to be the diameter. So a lot like a circle, and I think what did you call it, Lyndon? Sphere is you said sphere is a three-dimensional circle.
Yeah.
So that's one way that you could that you can think about a sphere. It's like a circle kind of stretched into three dimensions. So when we're working problems with spheres, all we really need to figure out, all we need to find is the radius. There's no base, there's no height, there's no slant height, there's no other information that we need really for what we're going to do other than the radius. One other piece of information that comes up in the homework is, we'll see the word hemisphere. Hemisphere just means half a sphere. So if we cut a sphere in half, that's what we call a hemisphere. So we talk about the northern hemisphere and the southern hemisphere, which means the northern half of the globe, the southern half of the globe. And it also turns out that Dodge engines that they call Hemis. The reason they call them Hemis is because the top of the piston, rather than being flat, has a dome on it. A hemisphere, so the top of the piston is hemispherical, and that makes more compression in the engine. So it makes them more powerful. So that's where the word. That's why they call those engines Hemis, is because the pistons are hemispheres on the top. So a little bit of trivia there. The way that we come up with formulas, the formulas for surface area and volume of spheres, a little more complicated than the other shapes that we've worked with, because the sphere is curved everywhere. So we're really not going to draw a net. We're not going to talk about how we come up with a formula. It's a little more complicated. And if you look at maps, sometimes they do maps where they try to make the globe flat, and they get a shape. You end up with a shape for your map that looks like this on the top, and your continents and everything would be here, and the oceans would be here, and then it kind of splits, and then there's some more stuff over here. So that's one way that they try to kind of make a net for a globe, but because it's curved everywhere, it's really hard to flatten it out. So we're not going to go into a lot of detail about where the formulas come from, like we did with the other shapes. So any questions about our parts of our sphere? All right, let's talk about our formulas. We'll do the surface area first, just because that's the order we've done so far. So the surface area of a sphere. Very easy formula. Surface area is 4 pi r squared, units squared. And r is just our radius. So nice, easy formula. We don't have to worry about bases, slant heights, anything else. All we have to worry about is the radius of our sphere. And I think it's kind of interesting that the surface area of a sphere is 4 times bigger than the area of a circle with the same radius. And our volume. Let's do both the formulas at once, and then we'll do some examples. Volume of a sphere. Volume is 4/3 pi r cubed. And our units are going to be units cubed. And r, again, is just our radius. So nice, easy formulas for the surface area and the volume. Now sometimes people get confused about this 4/3. You can think about it as 4 pi r cubed divided by 3. 4/3 just means multiply by 4, divide by 3. But usually you'll see it, 99% of the time you'll see it written as 4/3 rather than like this. But they mean the same thing. So questions on our formulas? Yes.
For the quiz, the hope sheet or whatever, is it going to have the 4/3 formula, or is it going to have the bottom?
I think it has this one. But they mean the same thing. Just means multiply by 4, divide by 3. No questions? All right, let's look at some examples. So we have a hemispherical dome, and the diameter is 142 feet. We want to find the volume. All right, first off, it says a hemispherical dome, so what are we talking about? Half a sphere. So if I were to draw a picture, they don't give you a picture. Drawing a picture helps, or can help. So we have a dome that looks like this. It turns out to be pretty big. And it says the diameter all the way across is 142 feet. So since our hemisphere is half a sphere, what do we need to do to find the volume? We know the formula for the volume of a whole sphere. So what are we going to do with that once we get it? Divide by 2. Volume of a hemisphere is half the volume of a sphere. So our volume is going to be 1/2 whatever we get for our volume calculation, 4/3 pi r cubed. So we just find our volume divided by 2. So we need the radius. How are we going to figure out the radius from what we have here? 142 divided by 2 comes out to be 71. So I'm going to plug that in and calculate. So that's all I have to do. 1/2 4/3 pi times 71 cubed. When I cube 71, I get a pretty big number. 357,911. And then I'm just going to multiply this by 3.14, multiply that by 4, and divide by 3. And then divide it by 2. So let me do the step in between first. I'm going to multiply this by 3.14, multiply it by 4, and then divide it by 3. When I do that, I get 149,845, 4.01. So what I did to get this number, multiplied 357,911 by pi. Whatever I got there, I multiplied by 4, and then I divided the answer by 3. And that's what gave me this. Then I'm going to divide this in half, just divide by 2, and I get 749,227.03, and my units are going to be cubic feet. So pretty good sized volume inside that hemispherical dome. Yes.
Can you go over what you said? The step up before the answer.
From here to here.
Yeah.
So what I did was I did 357,911. I multiplied that by 3.14. So I'll go over here and do that. No, and then I got an answer for that, and then I multiplied it by 4 for this part, and then divided by 3. So I can show those intermediate steps there. So 357,911 times 3.14, I get 1,1,2,3,840.54, and then I multiply that by 4. So I multiply that by 4, and I get another really big number, 4,495,362.16, and then I divide that by 3. And that gives me that number. So that was the steps in between there, yeah.
But can you do it in terms of pi? Or would it be like
Usually with the sphere, because you have that 4/3, you're going to end up with a decimal anyway. So usually with a sphere, unless they give you some like a very special case, usually you're going to put it in decimals. And on the test, I think on the test we say I take either answer, either in terms of pi or as a decimal. It doesn't on those projects doesn't say one way. Okay. All right, so let's look at another one. We have a baseball. The diameter is 2.9 inches. We want to know how much leather to cover it. So we're talking about surface area, volume. Surface area. We're talking about how much goes on the outside. So this question is, what is the surface area? So we know that our surface area is 4 pi r squared. So we need the radius. So how do we find the radius here? 2.9 divided by 2. And I get 1.45 for my radius, and I'm just going to plug in and calculate. So surface area, you get 4 pi times 1.45 squared. So I get 4 when I multiply this out, 4 pi. When I square this, 1.45 squared is 2.1025. Multiply that by pi, and then multiply by 4, and I get 26.42 square inches. So baseball, what's that? I might have just used, it depends on what I use for pi, how many decimals I use for pi. So 4241, that's going to be right there. So this baseball takes almost 26.5 square inches of leather to cover this baseball. Questions on that example? Pi, and then by 4. Mm-hmm. Mm-hmm. All right, well, let's do one last example, kind of a backwards example. I wanted to say one thing on the last example, on the surface area, or on the volume example. On your calculator, most of you, if you have a calculator, a Texas Instruments calculator, more or less like this, to cube a number, you put in your number. So what I did here in the calculator is I did 71, and then you have a button that looks like a little arrow, and then you hit the 3. So that's 71 cubed on your calculator. If you have a different kind of calculator, it might be a little different, but most of them are going to be something like this. All right, last example. We're going to do a backwards example. So we have a sphere where our volume is 1,000 meters cubed. We want to find the radius. So this is one where we already have the volume, so we need a different part of the formula. We're going to plug what we have into the formula, solve for what we don't have. So we know that our volume is 4/3 pi r cubed. The volume is 1,000 cubic meters. So 1,000 equals 4/3 pi r cubed. And we need to solve for r. So what is going to be our first step? What do we want to do first? What is it? Multiply by 3. So we have a 3 in the bottom of a fraction here. So let's multiply both sides by 3. I'll just move my equal sign over a little bit. So multiply by 3. So I get 3,000 equals 4 pi r cubed. So what do we do? What are we going to want to do next? Can we uncube it yet?
No.
No, we have to get the r cubed by itself first before we uncube it.
So, divide by 4.
Divide by 4? Okay, so let's divide by 4. So those cancel here. Have to write those cancel. And 3,000 divided by 4? We get 750 equals pi r cubed. Now what do we do? Divide by pi.
What do we just use 3.14?
And when we divide by pi, those cancel there. I'm just going to turn my equation around. R cubed equals, and 750 divided by 3.14. 238.85.
Now we uncube it?
Now we can uncube it. We have r cubed by itself. Now we can uncube it. And what do we call uncubing? The cubed root. So we take the cube root of both sides. The square root undoes squaring. The cube root undoes cubing.
Now where did you find that on the calculator, Mr.
You just put the 3 and then the square root?
So what you do on your calculator, if you have a calculator like this, you have a button that's above. So if you look at your button that looks like this, the little up arrow button,
Yeah.
you have one that looks like this. So the shifted, it's printed in blue. Or sorry, it has the X here. So the shifted key above the up arrow says X, and then the little root. So to find the cube root of this in your calculator, you would do 3, and then you would hit the second button. So I'm going to write the buttons here. The second button, and then you hit the key that has this above it. So that tells us to do the cube root, and then you would put in your 238.85 and hit equals. And we get 6.2. And our answer would be in meters. If you have a different calculator, it's going to do cube roots a different way. And if you're not sure how to do it, I can lift your calculator and show you how to do those. But to undo a cube, we take the cube root. And all of your calculators should be able to do a cube root. So any questions on that example? All right.